Hello, ladies and gentlemen of algebra. We are continuing on in chapter 8. We are going into the second section, and we're going to continue with this idea of the greatest common factor. Okay, so we're still in unit 8. We did those 4 sections in chapter 7, and now we're bumping along in chapter 8. Now, factoring is going to be similar to what we talked about with the GCF, the greatest common factor, in the sense that we're going to use this greatest common factor in order to do some factoring. Okay, if we remember the distributive property, the first piece of our notes today is going to be kind of like the undistributive property, the backwards of the distributive property. Instead of taking 3 times x plus 5 and going like this and saying, hey, my answer is 3x plus 15. We're going to be given this and be asked to go in this direction, where you take something common out. So look for that greatest common factor. You divide it out instead of multiply it through. Okay, we're going to talk about 2 special cases of factoring when we have some interesting things happening with negatives. Some of you asked me yesterday, when is the greatest common factor a negative number? If we have 2 items, like negative 4 and negative 40, okay, their GCF would be negative 4 because they both have that negative, negative 1 times 4, this is negative 1 times 40. Okay, they both have a factor of negative 1, and that's kind of similar to what we're going to be talking about here with this special case. And then also when our GCF, the thing that we're going to multiply through, is a binomial. Okay, and then last but not least, we're going to factor 4 terms by grouping. Okay, so that one is a little bit tricky, but if you hang on through me with the first 2, I'll try my best to make that third item there as easy and simple as possible. So let's get started. The first thing we need to remember in order to start factoring, and this is something new that we haven't done ever before. Okay, a lot of the beginning of algebra is review of pre-algebra and things that are similar, and this is probably not going to look very similar to anything you've done before. So stick with me. The distributive property, we're going to review that. The distributive property basically takes this item that's outside a set of parentheses and multiplies it. Okay, 2x times this whole quantity means I need to do 2x times x, and I need to do 2x times 6. And what that would be is equal to 2x squared plus 12x. Okay, what we're going to do today is the reverse of the distributive property, the backwards, going in the opposite direction. I'm going to give you this and say, factor it. How do you factor it? You basically look for that. Okay, so if you can keep that in mind, it's the backwards, it's the reverse, it's like undistributive, I sometimes say. That'll make it, hopefully, very quick and easy to make sense. So, this is that same problem that we just saw above. If I want to factor this binomial, I want to factor, I want to look for, okay, I'm still doing like what I did yesterday. I look for the GCF, and I divide it by each term. You don't really need to write down all these steps. This is number 2. Divide it by each term to factor it out. So basically, if I'm looking at 2x to the second power, 2x to the second power is equal to 2 times x times 6. 12x is equal to 2 times 6 times x. Okay, what do they have in common? They have this 2 in common, and they have this x in common. Okay, so their GCF is going to be 2x. This is exactly kind of what we did yesterday, so hopefully that's feeling familiar, feeling good about what we just did there. So, I already had it written. This is the same thing that I already wrote over here. But yes, that's going to help us find the GCF. If the GCF is 2x, I'm going to make it look like something like this up here. Okay, where I take that greatest common factor and I pull it out. I divide it out of each of these terms here. Okay, and is this fully factored? Well, no, because I took out only an x. As you can see, each of these terms here still has a factor of 2 that's inside of it. So let's look at, what is this answer actually going to be? If my GCF is 2x, I take this term, this binomial up here, and I take out a 2x. make it look like a problem that would say, do the distributive property. I take out a 2x. If I take this and I pull out, I actually erase this here because I think it's kind of in the way. Okay, with my binomial of 2x squared, get this looking nice and clean here. With my binomial up here of 2x squared plus 12x, I want to pull out from both of them a 2x. Okay, going in the opposite direction of the distributive property. If I divide out that 2x from each term, like I did here, what's going to be left here? When I divide out 2x, all that I'm going to be left with is x. I'm going to make this look a little bit cleaner again. I keep kind of messing it up. So if my GCF is 2x, I'm going to take this and I'm going to pull out the 2x. And what am I going to be left with? Well, just an x. Because if I have 2x squared and I divide it by 2x, the 2's are going to cancel, and 2 minus 1 is just x. I don't have anything left besides x. If I do the same thing to this one here, I take 12x and I divide out my 2x, well now my x's are going to cancel, and all I have left is a factor of 6. So this would be my final answer here. Okay, and if you're not sure how I got that, try and check it by actually doing the distributive property. 2x times x, this first one here, 2x times x is equal to 2x squared. 2x times 6 is 12x. Is that what we started with? Yes. Okay, so let me do some more examples and I think it'll make sense. It'll be a little bit more clear. So let's try another. Oh gosh, I'm sorry. I have some nice steps here. I guess my steps here were kind of sloppy, weren't they? So we got these steps here, we got some better ones on our next slide here. Okay, so I have basically 4 steps for just factoring a binomial. The first thing you're going to do is find the GCF. So now I picked a different example. I have 3x squared and 12x. The greatest common factor, that's what we did yesterday, we can list out our factors. Basically I have a 3 in common and I have an x in common. So therefore, my GCF is going to be 3x. I can divide a 3x into both this term evenly and this term evenly. And then I'm going to write each term as a product of that 3x. So for example, 3x squared comes from 3x times x. What will be left over? 12x comes from 3x times 2 times 2 or 4. Okay, when I take this, 3x from this one, and 3x from this one, and I pull them out as if I'm dividing them out, doing the opposite of the distributive property. It's called factoring it out. Okay? When I pull that 3x out here, what am I left with? Well, just an x. When I pull this 3x from the second term, what am I left with? 2 times 2, which is in fact 4. Okay, so this is my answer here when they ask me to factor. If you want to check it, which you should, okay, check by distribution. If you're not sure if it's right, just simply distribute and see if you get what you started with. This one here is going to be 3x squared. 3x times x is 3x squared plus 3 times 4 is 3x times 4 is 12x. Is that what I started with? Way up there? Yes. So I know I got it right. Okay, now is when we're going to do that practice that I mentioned earlier. So let's practice some. Okay, this first one here, 2t squared plus 4. So I'm going to write everything as a list of its factors. 2t squared is 2t. 2 times t times t. And then 4 is 2 times 2. So what is my GCF? My GCF, well, the only thing that those numbers have in common is just a 2. So what I'm going to try and do is pull out a 2 from this term and pull out a 2 from that term. Divide it out. So I'm going to put my 2 in front here. When I do, when I pull that 2 out, all I'm left with, I guess I can underline these in green, all I'm left with is t squared, 2 times t. When I pull the 2 out of the second one, what am I left with is 2. Okay, so it makes sense that if you do the distributive property, you're multiplying. If you're going to factor, being the opposite, you're going to divide something out. Okay, so let's try another one. Let's try another one. And actually, I think I'm going to have you guys try this one. Try this but I'd like you guys to try it in your notebook if you're feeling ready. If you're not feeling ready, watch me for a little bit, but I'm most definitely going to have you guys do number 3 on your own. So here it goes. I'm going to work up here silently. You give it a shot in your own notebooks. And I'm done. If you're not done, press pause. If you are done, do you have the same as I do? Okay, I found that my GCF is 5G. When I pulled 5G out of my first term, I was left with, I did it in blue. Okay, what I was left with was G squared. And when I pulled 5G out of my second term, I was left with 4. So G squared plus 4 in the center. Number 3, I want you guys to try this one definitely on your own. I'm going to work way over here in the corner, and I'll be writing as you guys write. But give number 3 a try. You're looking for the greatest common factor of all 3 of those things. All right, ladies and gentlemen, I'm finished. If you are not finished, press pause. If you are, take a look, and hopefully you have the same thing as I have. I found my GCF to be 4F. They both had a factor of 4 in the coefficients, and they also had a factor of an F, just one F term. When I pulled 4F out of my first thing, I was left with 2F to the second power. When I pulled 4F out of my second term, I was left with just an F. And when I pulled 4F out of my third term, I was left with just minus 4. Okay, be careful that you have minus signs in between all of those. We're not going to try and change the symbols. But hopefully you're feeling good about factoring these binomials. Okay, if not, go back and try them again. But I'm going to move on. Okay, so now we're going to talk about some special cases. If you are looking at this example problem here, and both of your terms are basically negative. You have negative 12x to the second and negative 14x. You want to pull out a negative 2 on both of those as far as its greatest common factor, and then also the x. Okay, so I'll write this out to make it nice and clear. Negative 12x to the second is, let's see, I guess I could do negative 2 times 6 times x, and 14x would be negative 2 times 7 times x. So what do we have in common here? We have a negative 2 here, and we have an x. So that's why your GCF is a negative 2x. So it just happens if everything is negative here, pull out a negative instead of leaving both a negative here and a negative here. Okay, and then also, my other special situation is sometimes your GCF can be a binomial. Okay, so I have 5 times x plus 2 plus 3x times x plus 2. Well, both of these terms have this factor x plus 2. So if I take this x plus 2 and I divide it by both of them, and I pull it in the front, that's what I have here. I put that first. And then what's left? Well, what's remaining is the 5 in the first thing, and the 3x in the second thing. Okay? So both of these have this factor of x plus 2. If I were to take 5 times x plus 2 and divide out in x plus 2, because this is in parentheses here, these entire thing will cancel out, which is why you just have this 5 that's left. Okay? So you can possibly factor out a binomial. That could happen from time to time, and that's actually, I think, what's going to be some of our next problems here. Okay? If you have questions on this, just write them down. I'd be happy to explain it in a little more depth tomorrow, if you need, on both of those special cases. Okay? Now we're going to factor by grouping. So sometimes we might have 4 terms. Okay? And when we factor something out of maybe the first 2, and I factor something out of the second 2, you might find something interesting. Okay? So when a polynomial has 4 terms, you can possibly make 2 groups. Okay, group them together like this. Look for the GCF in each of your groups, and something interesting might happen. Let me show you. So this first one here, if I look for the GCF of these, hopefully we're starting to see it a little bit quicker. Our GCF would be 3x to the second power, because they both have at least x squared. And then for this one, our GCF would be equal to, they both have a factor of 5, and I guess a factor. Okay, so watch what happens when I take 3x to the second out of here, and I take 5 out of both of those. I'll write it out a little bit clearer. So here, I took a whole step just to write the parentheses in, which I've already done. Up here, I'm going to get rid of these arrows just so it's not cluttered. Then, like I said, I'm going to factor the greatest common factor out of this one. In this case, it happened to be 3x to the second power. This one here, I'm going to factor out a 5. And when I do that, notice, this problem is set up in a way that I get the same binomial there. I get the same binomial here, 4x minus 3, and I get 4x minus 3. Well, this goes back to the slide we just did. If I have a number, a thing, multiplied by 4x minus 3, and another one multiplied by 4x minus 3, I can take this, and factor it out of each of them. Okay? So I factor it out of each of them. It ends up here. And what's left is 3x squared plus 5. 3x squared plus 5. Okay, let's try another. Let's try this one together, see if it makes it a little clearer. So, group the first and the second with the third and the fourth. And if you write them in standard form, that's pretty much how you're always going to group them. Just think first 2 go together like this, and the last 2 go together. If they're not in standard form, you might want to check out writing them in standard form. But my first step, my first step is to make the groups and look for factoring. In this case, what would my GCF be? Hopefully we're starting to get quick at this. A factor of 2b to the second. And my GCF of the second one would just be 3, I guess, right? Okay, so I'm going to look to factor out 2b to the second. I'm going to look to factor out 3 in the second group. Okay, when I do that, let's start with the first one. Okay, when I do that, I divide 2b to the second from this one. All I have left is a 3b. And if you're not sure how they got that, just write it out. 6b to the third is 2 times 3 times b times b times b. If I were to divide out this greatest common factor of 2b to the second, what's left? 3b. Okay, same with 8b to the second. 8b to the second is 2 times 4 times b times b. My greatest common factor is the 2b to the second. Well, what's left? Just a 4. Okay, my second group, I'm going to factor out 3. Okay? In this one, I want to take out 3. So 9b divided by 3 is all that's left is 3b. And 12 divided by 3 is all that's left is 4. So, we see that here. When I take out a 3, when I divide out a 3 from this whole binomial. And what's really interesting is that we get the same term here. 3b plus 4. So that can get taken out in front. Undistributed property again. And I get the 3b plus 4 here. And I get the 2b to the second plus 3 is what ends up here. Okay, there's a multiplication in here for the same reason. Let's look at maybe when it's not a binomial. Let's review that again, because maybe that'll make it clear. If I'm, for example, taking something very basic, 10x plus 5, and I want to factor that, what can come out? I can divide out the GCF of 5. So when I take out 5, notice there's a multiplication in there. That's the same multiplication that's happening there. Okay? What would I be left with? 2x plus 1. Okay? And what's really kind of funny here is if you don't believe me, FOIL this. FOIL this and you'll end up with what we have up there. Okay? So this last slide is definitely the trickiest of the section. Go back and watch it again, try it again, review it again. If you're feeling kind of confused, write down some questions. I'm happy to help you out. Okay, we can even practice some more in class tomorrow. Okay, and last but not least, this is kind of a special case of what we just did earlier. So let's try this example problem here. Okay, yeah, I guess I already wrote it here. Let's try this example problem here, exactly like what we did before. Exactly like the previous slide. We're going to group these together, we're going to group these together. We're going to look for a GCF. In this case, my GCF is, I have 3x to the second. I'm going to try and divide out 3x to the second on each of those terms. Alright, I can write it out so you can see where it comes from. 3 times x times x times x. 15x to the second is equal to 3 times 5 times x times x. So, if, going back to my GCF here, if 3x to the second is my GCF, for each term I'm going to pull out 3 and 2 x's, 3 and 2 x's. What's remaining here is what's going to be left inside of your parentheses. So hopefully, if I did this correctly, I will have x minus 5, exactly. X and 5, the minus just comes from what was already there. And on this one here, my GCF would be 2. Just a plain old 2. If I factor out a 2, oops, where is that? Oh, weird. If I factor out a 2, you might notice that, usually in these problems, I was getting the same binomial on the inside. I have x minus 5 and 5 minus x. Those aren't the same. Well, with a little bit of magic, I can make them be the same. Let's maybe look at this plus 2. Instead of factoring out a plus 2, I might change it and factor out a minus 2. Okay? What happens then is instead of having these two binomials here be opposites, if you also factor out a negative 1, this is going to turn into negative 5. And this one is going to turn into plus x. So now I have 5 plus x, which is the same as x plus 5. The order doesn't matter when I add or subtract. So therefore, I'm sorry. It's going to not be x plus 5 because this is a negative 5. It's going to be negative 5 plus x, which is the same as x minus 5. That's what I want. Okay, so x minus 5 and x minus 5. Now they're going to be the same. And what I can do is I can take that x minus 5 out of both of them. And I don't really like the way that that's written because I think it's going to confuse you. This x minus 5 and this x minus 5 can get factored out here into the front. So I have x minus 5 times 3x to the second power. And what's left on the other side should be just a minus 2. Okay, so to review what it says up here, if you get binomials that are like in the opposite order but subtraction, one is x minus y and one is y minus x, you're not actually done yet. Okay, these are called opposites. You can change one to the other by factoring out a negative 1 in just one of those instances. Okay, I didn't do anything really with this piece of it. I just factored, instead of a positive 2, I factored out a negative 2. Okay, we'll practice those a little bit more tomorrow. I have another example here. Why don't we do this one together just so it can really drive home the point here. So let's group them together. What am I going to factor out of this first group? My GCF there is simply going to be 8. What do I want to factor out of the second group? My GCF here would be variable x. Okay, so when I take out 8 here, I have y minus 1. And then, when I factor out an x, I'm left with negative y plus 1. Well, here I have a positive y, here I have a negative y, here I have a negative 1, here I have a positive 1. It seems like I should be stuck. But let's change this part here. Okay? Instead of factoring out positive x, let's factor out negative x. So then what happens is back up here, let's look back up here. If I take out negative x, I'm going to be left with positive y. And if I take negative x out of this one, I'm going to be left with minus 1. And I didn't really change the first one. So if I change both of them, I've changed them both to their opposites, and I'm back to where I started. And what you're going to notice, hopefully, is now these are the same. This is what I'm looking for. And then this piece and this piece here can get factored out of each part. And what happens is I have x minus 1 being multiplied by 8 minus x. Because those are the pieces and parts that are remaining. Okay, I have an 8 remaining here. I have a negative x remaining here. So that's why those parts are left there. Okay, this was a multiplication here for the same reason that when you take out a 3, it's a multiplication there. Okay, it's just which part did you take out? We took out a 3. We took out a y minus 1 here, and then it's times whatever remaining, in this case it's x minus 3. Okay, so this one makes sense, and hopefully this one also makes sense. Let me know tomorrow what kind of questions you have. Again, this is new stuff, so let it settle in your brain a little bit. Don't be super stressed or confused or stressed out if it seems a little tricky at this point. The more we practice it, the better at it you will get. Okay, so we started with just undistributing. We take out something common from this. We talked about when we have two negatives. In this case, you want to factor out a negative 2 so that you have x plus 3. And then we also talked about when your GCF is a binomial, which also goes into there. And you have 4 terms by grouping. Okay, so we'll practice some more tomorrow. Go back and review anything that you're feeling a little bit confused on, and I'll see you ladies and gentlemen tomorrow.